Assalamu alaikum. Today in this lab we are going to apply stack to convert an infix expression to a postfix expression. Infix expression and postfix expressions, as we have seen in the class, are two distinct notations to express mathematical expressions or equations, and they are both basically equivalent in essence, but they have distinct properties in terms of evaluation, so that it becomes easier and straightforward to evaluate a postfix expression as compared to an infix expression, because an infix expression, it has its limitation of operator precedence, as well as the parentheses. We have to use parentheses in order to specify the operator precedence. So before moving to implementation, I would like to explain a little bit about how infix expressions are evaluated, and how the postfix expressions are evaluated manually. Okay, so for that it would be nice to elaborate the algorithm for infix to postfix expressions. The algorithm is pretty much straightforward for evaluating a postfix expression, which you will do as a lab activity. But for this lab demonstration, I would show you how to implement the algorithm to convert an infix expression to a postfix expression. So basically, before explaining this algorithm, it would be nice to see how an infix expression works and how a postfix expression works. So let's suppose there is an expression, say 2 plus 3 minus 7 divided by 8 divided by 8 minus 12. Okay, let's assume we are dealing with single digit numbers, so the valid entries are just 0 to 9. Okay, for the sake of simplicity for now, multiplied by 3. Okay, and let's suppose we also introduce parentheses in this expression. So let's suppose we have 2 minus 2 minus 5 in a parenthesis. So we have this expression. So this expression is an infix expression. Okay, this is an infix expression because according to the definition of an infix expression, whenever the operator is specified between the operands, that notation is known as infix notation. Okay, and in contrast to this infix notation, there is Polish notation known as prefix or postfix notations. In prefix notation, the operator is written, for example, in prefix notation, the operator is mentioned first. For example, plus 2 3 minus 7. This is not the prefix notation for the for this given infix expression. Okay, I'm just assuming a separate distinct expression just for the sake of explanation. So in in prefix notation, the operator is mentioned first and then the operands are mentioned, and in postfix notation, the operator is the operand is mentioned or not specified first. For example, 2 3 and then the operator plus and then for example let's suppose 7 and then minus, and so the operand as you can see are mentioned first and then the operator applied on those operand is mentioned. So this is the uh, basic introduction of infix expression and prefix or postfix notation. We would be dealing for now in this lab with just the postfix notation. I would show you that getting a prefix notation is as simple and straightforward as converting it to a postfix notation. There is not much to do extra. So okay, why do we need postfix notation? Because as you can see, if there is no parenthesis mentioned in an expression, then the operator precedence becomes ambiguous. Then the order in which an operation is performed, the expression is the order in which this expression is evaluated, it becomes ambiguous, because if you evaluate this expression from left to right, then 2 plus 3 is evaluated first and the result is subtracted from 7 is subtracted from the result, and then the result is divided upon 8. However, if we take into account the operator precedence, then this division operation should be performed first, this multiplication should be performed next, and then from left to right the precedence, according to the precedence, we would evaluate. But since the operator precedence is not made prominent by the use of parentheses, so without parentheses the evaluation of this expression becomes ambiguous. Okay, so but in case of postfix notation, as we will see by the end of this lab, this ambiguity is removed because that's how the infix expression is converted to postfix expression, and the ambiguity of operator precedence is removed. Okay, so now knowing what is an infix expression and what is postfix expression, next there are certain rules, or you can say algorithm based upon those rules, which specify how to convert an infix expression or an expression in infix notation to postfix notation. So we would go through those rules one by one, and then I would explain them to you in manually, and then we would move towards the implementation of that algorithm. So the rules say that print operands as they arrive. Okay, so one thing is that printing here would suggest, for example, here in your lab sheet also the algorithm is mentioned and printing is mentioned, like here print inputs. So printing suggests that you given an input, an infix expression, you have to get this postfix expression, and this is your output. This would be the output of the program or the algorithm. Okay, this postfix expression. So printing means that this, if I say print 2, it means that bring it to the output string, or add it to the output string. Okay, so whenever there is an operand, print operands as they arrive. Okay, so in an infix expression, whenever there is an operand, you just have to what you have to do is you just add it to the output string. For example, 2 is an operand, so you just bring it here to the output string. Then for example, ignoring this plus 3, you have to just bring it here. 7, you have to bring it to the output string. Okay, for the operands, the result, the decision or the action is straightforward, that you have to bring it to the output string. Now if the stack is empty or contains a left parenthesis on top, push the incoming operator onto the stack. Okay, for example, here, okay, let me make a stack as well, so that we have a more fuller mechanism going on. Let's suppose this is our stack, okay, and the stack size, as because we are yet dealing with stack implemented as an array, so its size is predefined and fixed. And as you can assume that as you can predict that the size of this stack would be equal to the size of the characters in this input string, which we have to convert to postfix. This infix expression, the number of characters in this string, would actually give the size of the stack. Although, as you would see soon, that it's not necessary that if there are let's suppose 15 characters in this string, so we make a stack of size 15 and all it gets filled entirely. It's not necessary, but just to be on the safe side, we we initiate the stack with the size equal to the length of the string. But since you can see that the operands are directly output to the output string, or directly attached to the output string, they don't go to the stack, so this stack is not necessarily entirely filled. Okay, so whenever there is an operand, we have to just we have to output it directly. So there is a 2, so this is directly output to the output string. Then there is plus, an operator appears in the input string. Okay, so now, as this rule says that if the stack is empty or contains a left parenthesis on top, let's for a while ignore this left parenthesis on top thing. So if the stack is empty, push the incoming operator onto the stack. Okay, so since the stack is empty, so we got a plus. We just add this plus here. Okay, now move to the next character. It's a 3. So what we would do is just attach this 3 to the input the output string. Okay, 2 3 please don't mind the alignment of the characters, because I'm not very used to using this paint software. Okay, so 3 has been attached. Now again, there is an operator minus. Okay, now the stack is, as you saw here, if the stack is empty, then we directly push the operator onto the stack. But now the stack is not empty, there is a plus sign already. Okay, I'm not mentioning the exact procedure of pushing and popping from the stack, because we have already seen in the previous lab that there is index T or top of the stack, and that is initially -1, and then we increment it and it becomes 0, and it points to 0, and then we add this plus here, and then it increments, and then we add another operator. So that should be known and understood already. Okay, so now the stack is not empty, and this rule says that if the incoming rule number 3 says if the incoming symbol is a left parenthesis, which is an opening parenthesis, so push it on the stack. But now we have a minus operator, which is not a left parenthesis as well. If the incoming symbol is a right parenthesis, pop the stack and print the operators until you see a left parenthesis. Discard the pair of parentheses. Okay, we will come back to it later. Now, if the incoming symbol has higher precedence than the top of the stack, push it on the stack. Okay, so you should be knowing the precedence of operators, which is plus and minus have same precedence. I would just summarize here: plus and minus they have same procedure. Let me represent it like this: plus and minus, they have same precedence, which is less than multiplication and division. Okay, multiplication and division, this equal symbol, it represents that plus and minus have equal precedence, which is less than the precedence of multiplication and division, which is same or equal, which is less than the um, precedence of exponentiation. Okay, exponentiation, for this lab we are not considering this exponentiation operation. This calculator, the postfix notation would not include an exponentiation operation, but just for the sake of knowledge, this is the precedence order. Okay, so the rule is then that whenever there is an operator in the infix expression and the stack is not empty, it already has an operator, then you would compare the precedence of these two. You would compare the precedence of this incoming operator and the operator on the stack. Okay, on the top of the stack. So if this has a higher precedence, the incoming or input operator, it has higher precedence, then you just push it onto the stack. Okay, but if it has same precedence, which in this case it has the same precedence, minus and plus have the same precedence, so what you do is you check for association or associativity. Association is basically it is basically the mechanism of how the in what order operations or operators with same precedence are evaluated. Okay, there is a left association, which basically specifies that the operators with same precedence are evaluated left to right, and there is a precedence of there is an right association which states that the operators with same precedence are evaluated right to left. So in case of left association, you just what you do is you in case of left precedence, the incoming operator has a higher precedence than the one on the top of the stack. Okay, in case of right association, the incoming operator has lower precedence than the one at the top on the top of the stack. Okay, let me mention this here. Left association. Okay, when it's left association, the incoming the input operator, by input operator I mean the operator in the input string, which the input expression which we are going to convert to postfix. The input operator has higher precedence. Okay, the input operator has lower precedence. Lower precedence than the one on top of stack. Okay, and right association is the input operator has higher precedence than the one on top of the stack. Okay, this is just for the sake of clarity. In this lab, we are not going to deal with left associations. Okay, but just to reiterate, whenever the precedence of input operator and the operator on the top of the stack is equal or same, then we go for association. If it's left association, which is the case with plus and minus, which is the case actually with plus, minus, static, and multiplication and division, with all these operations they follow left association. Only the exponentiation operation, it follows right association. Okay, so in case of whenever the precedence of the input operator and the operator on the top of the stack is same, whenever the precedence is same, we check the association. In this case it's left association. Left association states that the input operator has lower precedence. So whenever the input operator is of lower precedence, what we do, we pop from here, we pop the stack. In this case, for example, we would pop we will pop the stack and bring it to the output string. Okay, so this plus comes here, and we push this input operator onto the stack. The minus comes here. Okay, next there is 7 will be directly output to the output string here. Next there is an operator, division. Now division has higher precedence than plus and minus, so whenever there is an input operator with higher precedence, we just push it on the top of the stack. So this division operator comes here. Next it's 8. So this 8 will, this is an operand, so it will directly be attached to the output string. Next it's minus. This minus has lower precedence than the one on the top of the stack. So what we will do, we will, whenever there is an input operator with lower precedence than the one on the top of the stack, we pop the operator from the top of the stack. So in this case we will pop this division from here and attach it to our output string here, and we will push this minus symbol to we will push this okay, this this minus had lower precedence than the division operator which was on the top of the stack. So we will push this, we popped this division operator, and then this will continue to the next operator on the stack as well. Now the top of the stack is minus, and this minus from the input string and this minus from on the top of the stack, they have same precedence. So we will go to check for the association. So it's a left association. Left association means the input operator has lower precedence. So if it has lower precedence, so it means that we will also pop this minus from here and attach it to the output string here, minus, and then we will push this minus to the top of the stack here. Next there is 1. So this one will be directly attached to the output string here. Then it's multiplication, a static. So this has higher precedence, so we will just push it onto the stack here. Then it's 3, so this 3 will be attached here to the output string. Then it's plus has lower precedence than this, so this multiplication will be popped from the top of the stack. And then minus, they have the same precision, left association, so this minus will also be popped, and then this plus will be pushed onto the stack. So both of these two popped, and the plus was pushed onto the top of the stack. Okay, so now there is a left parenthesis. As you saw here, if the stack is empty, if the incoming symbol is a left parenthesis, push it onto the top of the stack. So here we just push it onto the top of the stack. Then there is 2 will come to the output string. Okay, then there is minus. So minus sign suggests here, if you see, if the stack is empty or contains a left parenthesis on top, push the incoming operator onto the stack. Okay, so in this case the stack is not empty, but it contains a left parenthesis on top, so we will just push this minus here. Okay, then there is 5. This 5 will be output to the output string. Okay, here then there is a right parenthesis or the closing parenthesis. So whenever there is a closing parenthesis, okay, if the incoming symbol is a right parenthesis, pop the stack and print the operators until you see a left parenthesis. Discard the pair of parentheses. The pair of parentheses does not appear in the output string. It's just for for matching. You have to match the pair of the parentheses. So now there is a right parenthesis, so what you do is you pop this minus sign from there, and then there is this opening parenthesis, so you discard that, and the input stream, the input stream ended. So the when the input stream ends, if there are if the stack is not empty and it contains operator, you just pop all the operators and attach them to the output string. So in this case we only have plus, so we will pop this plus and attach it to here. So this is our postfix notation for this infix expression. Okay.